Black holes are the strangest objects in the universe. Unlike stars or planets, they have no fixed size limit. A star can only grow so large before it collapses. A planet can only grow so massive before gravity crushes it. But a black hole can keep growing forever, as long as there's something nearby to consume. So how big can a black hole actually get? Somewhere out there, roughly 10 billion light-years away, sits an object of almost unimaginable size. Its name is TUN 618. It may be the largest black hole ever confirmed. In this video, we'll explore just how enormous this object really is. We'll compare it to the other record holders in the running, and we'll ask a deeper question. Is there a limit to how big these monsters can grow? To understand something this large, it helps to start small. Most black holes begin their lives as stars. When a massive star runs out of fuel, it can't support itself anymore. Its core collapses inward under its own gravity. The outer layers are blown away in a supernova. What remains is called a stellar mass black hole, typically a few times heavier than our Sun. But that's just the beginning of the story. Over millions of years, black holes can keep growing. They pull in gas, dust, and even entire stars. They can also merge with other black holes entirely. At the center of most large galaxies sits something bigger, a supermassive black hole, built up over cosmic time. Most of these contain millions of times the Sun's mass. Some contain billions. A tiny few break every expectation we have. TUN 618 was first spotted back in 1957. At the time, astronomers had no idea what it was. It appeared to be nothing more than a faint blue star. It was catalogued and largely forgotten for years. It wasn't until scientists understood what quasars really were that TUN 618 was correctly identified for what it is: a supermassive black hole devouring matter with incredible violence. So violently, in fact, that it outshines entire galaxies. Today, TUN 618 holds the record for measured mass. Its estimated mass is around 66 billion times our Sun. To put that in perspective, consider the Milky Way's stars. That figure is more mass than all of them combined. This single object may outweigh our entire galaxy's stars. TUN 618 also shines with extraordinary, almost impossible brightness. Roughly 140 trillion times more luminous than our own Sun. That makes it one of the brightest objects ever observed. And that brightness isn't just a random coincidence at all. It comes from gas and dust falling in violently, heated to extreme temperatures as it spirals toward oblivion. Mass is one way to measure a black hole's scale, but what does that translate to in physical size? The boundary of a black hole is its event horizon. This is the point beyond which nothing can escape. Not even light itself can cross back over it. For TUN 618, this boundary stretches incredibly far outward. Astronomers estimate it spans roughly 2,600 astronomical units. That's about 390 billion kilometers from one edge to the other. To understand that scale, think about our own solar system. One astronomical unit is the Earth-Sun distance, for reference. Neptune orbits at only about 30 astronomical units out. That means TUN 618's event horizon alone is staggering. It could swallow every planet in our solar system. Not once, but more than 40 times over completely. If you replaced our Sun with TUN 618 today, its boundary would swallow every planet we know entirely. This isn't a star, and it isn't a galaxy either. It's a single object, larger than our whole solar system. Here's something important to understand about measuring distant objects. We can't observe TUN 618 directly, the way we'd study a planet. It sits billions of light-years away from Earth. Its mass has to be calculated indirectly through observation. Scientists study the motion of gas swirling around it and measure exactly how fast that gas is moving. Different studies have arrived at somewhat different numbers. Some peer-reviewed research puts its mass near 70 billion suns. Other estimates place it closer to 40 billion instead. The commonly cited figure is 66 billion solar masses. But scientists remain honest about the uncertainty involved here. Even the distance to Ton 618 is estimated differently. Figures range from roughly 10 to over 18 billion light-years. This uncertainty doesn't mean scientists are simply guessing randomly. It means they're honest about observing something this extreme. Every measurement still agrees on one basic point. Ton 618 is almost unimaginably, overwhelmingly massive, regardless of the method. Ton 618 might not actually be alone at the top. At the center of the Phoenix cluster sits another candidate, a black hole known to astronomers as Phoenix A star. Some estimates place its mass near 100 billion suns. If true, that would make it larger than Ton 618. However, more conservative measurements tell a somewhat different story. NASA's Chandra X-ray Observatory has directly observed this object. So has the newer James Webb Space Telescope more recently. These observations suggest a mass closer to 5.8 billion suns. Some estimates push that figure up toward 10 billion instead. That's still an enormous black hole by any standard, but it likely places Phoenix A star below Ton 618 overall. What makes Phoenix A star strange isn't just its size. It's actually how the black hole behaves around it. Normally, black holes this massive prevent gas from cooling. That usually stops new stars from forming nearby entirely. But the Phoenix cluster shows something completely unexpected happening. Stars are forming here at a furious, rapid rate, hundreds of times faster than star formation in our galaxy. Researchers describe this black hole as somehow weakened over time, allowing its host galaxy to essentially come back to life. Objects like these push the boundaries of what seemed possible. So an obvious question naturally comes to mind here. Is there an upper limit to a black hole's mass? Researchers studying these ultramassive objects have proposed something interesting. There may, in fact, be a theoretical ceiling somewhere. As a black hole grows, its feeding disk expands outward. Eventually, that disk becomes so large it starts collapsing. Instead of feeding the black hole, it forms new stars. This process could act as a natural brake overall, slowing or even halting growth of the largest black holes. There's also a deeper puzzle involving cosmic time itself. Black holes like Ton 618 existed when the universe was young, only a few billion years old at the time. For something to reach tens of billions of solar masses that early, it needed extraordinarily rapid growth to occur, either through constant feeding or through repeated massive mergers. Scientists are still working out exactly how that happened. Objects like Ton 618 remain a natural laboratory for these ideas. Let's step back for a moment and think about scale. Our sun feels genuinely enormous from our small perspective. It holds over 99% of our solar system's mass. More than 1 million Earths could fit inside it easily. And yet, next to Ton 618, our sun barely registers. Less significant in comparison than a single grain of sand. A black hole with 66 billion times the sun's mass, with an event horizon vast enough to swallow our solar system, not once, but dozens of times over, completely. It's difficult for the human mind to truly grasp. These objects remind us how vast the universe really is, and how much we still have left to learn. So, what do you think? Could there be an even larger black hole out there that we simply haven't discovered yet? Leave your thoughts in the comments below. Don't forget to like this video, subscribe to our channel, and share it with your friends so you never miss another fascinating video.